In this video, I'm going to show you how we can take our results from running the Kraken 2 app on Galaxy. You can see that each line, each row of data has a classification and the number of reads that align to that classification. Some of this data is at the domain level, some is at the phylum level, some is at the family level, some is at the species level. We want to be able to separate out the different levels of classification for making different graphs and different reports for our microbiome project. So let's see how to do that step by step. First thing we're going to do is download the file, open it in the downloads folder, and I'm going to drag it to my folder that I'm using as an example. grepl. You can think of the grepl function as being similar to find and replace. This grepl function is going to allow you to look for data that matches a particular set of characters. So similar to equals equals that we used for our numeric filter in the empty cars homework, we're now going to look for a set of characters using the grepl function. So I'm going to paste from the RStudio publication that is linked in the assignment. I'm going to paste the code that I used, and I'm going to modify it for this particular file that I'm downloading from my own history. So the first thing I'm going to do is change the information so that it has my name and the date. Then I'm going to change the name of the file that I'm reading in and check that the formatting works well. So I use the tab key to be able to finish typing in the file name to make sure that I spell it correctly. I'm going to run that one line of code and look at it before I do anything else. So I see that there are two columns, V1 and V2, because the columns didn't have column names in the tabular file. I can see that it looks like it read incorrectly. I'm going to scroll down to make sure that none of the names got pushed over. If I see a third column or I see any data that has been misaligned, I'll want to fix that before I go on to the next step. So that looks like it read in perfectly all 331 rows. So now I'm ready to isolate just the rows that have this special character. A straight pipe symbol, the straight up and down line, and an S. Since this has a special meaning in R, it's the symbol that we used in logical statements to mean or, I have to put // in front of it so that it looks for this character literally instead of treating it like it means or. Because the data that has the species name is in the first column, I'm going to filter based on all tax V1. And if I run this line, I should end up with a shorter data frame, still two columns, that only contains species. So if I make this bigger, I'll be able to see, if it's wider, that it is actually species names. Sorting really well by that, but we can make it a little bit bigger. And it won't quite fit in the window, but it is actually the species names. We could test it on the console by looking at S rows, just looking at the first row of data, and you can see that it is classified not just at the genus level, but we have this pipe symbol and the S, so it's been classified at the species level. Once we have only the species names, you can see that these names aren't very usable. They're really long. They start with the domain, phylum, class, order. They have all of this additional information, and we really just want the last part. We can do that with the gsub function. Gsub looks for a string. Here it's going to look starting with the letter D going all the way to the letter S, followed by these underscores. The asterisk symbol means it's looking for things in between, anything can be in between those two characters. And it's going to go through each row of S rows and replace that text. When I run this, I see that this stayed the same size, but when I view it, all of the species names are a lot easier to read. Now we're ready for the last step, giving column names, so it's not just V1 and V2, and writing this out to a new file. We'll use grepl and gsub throughout this semester. This is sort of our first introduction to them. And I think it's really helpful to think of them like find and replace in a word processor. This is something that you are going to want to do for all kinds of bioinformatics data because we often don't have numerical data, we have text data. Things like genotypes are going to show up as a character string, and so it's really helpful to be able to compare rows and columns of data that contain characters, not just rows and columns of data that contain numbers.